Large language models have dominated the headlines for nearly 3 years. We're seeing some mixed narratives: magical transformation versus measured skepticism. Are we building the future or chasing hype? I'm Owen Cho, Chief Strategy Officer and Chief Technology Officer at DeepSkill. We build decision-making AI. Extending from this project, we are curious where all this wave is heading to. Today, we have Dr. Stefano Mezza, who's going to share some insights from the recent ACL conference. I'm very much looking forward to this sneak peek into the academics' view at the forefront of all this wave. Hi, Stefano. Thanks for joining us today.
Hi, Owen, and thank you very much for having me.
So I know you have been quite a prominent figure in this field, but for some audience who may not be familiar with your domain, can you just briefly explain yourself to the audience?
Absolutely. Yeah. So my background is in a subset of artificial intelligence that's called natural language processing. And this deals with taking natural language, which is basically any language, English, Korean, Japanese, Italian, and turning it into something that machines can understand.
I see. Wow.
And I started specializing in this field in 2017. Mm-hmm. So my background is in computer science. I did my bachelor's at the University of Bologna in Italy and my master's at the University of Trento in Italy. And back then, artificial intelligence was very different from what we have today. LLMs did not exist, and most of the chatbot systems, those that are not very, very, very young. So for some people, this is already new, but we remember Siri, right? The very early conversational agents that we had on the phone, they were built on just parsing natural language and turning it into data structures for machines. And I started specializing in NLP right at that stage when things were starting to move in the direction of machine learning. And I did my first commercial dip into natural language processing with Amazon Alexa. I was part of the Amazon Alexa Prize 2017. This was an inter-university competition to develop software for Amazon Alexa that was designed for open-ended conversation. So just having a companion you could chat to.
Right.
And I really enjoyed that. So after that, I worked for a few years in London as machine learning engineer and applied scientist. And during that time, I started drafting my idea for a PhD project, which was centered on building conversational agents that were able to understand your point of view a bit better than what we had at the time. So this was the center of my research for the last few years. I've done my PhD at the University of New South Wales in Sydney, Australia. And I just graduated less than a year ago, so it's quite recent. And right now I'm working as a lead argumentation scientist for DeepSkill, where I'm trying to put all of my studies on insightful understanding of critical thinking and reasoning into practical applications for consumers.
Wow, I see. Again, congratulations for your recent graduation.
Thank you.
Okay, so it sounds like you look at the genesis of this all magical LLM from the first time. So for you, I think it might be quite meaningful moment for you to have a look at this year's ACL conference. But before diving into the meaty part of that ACL content, why don't you have a kind of brief introduction of what ACL is and why it is significant for the general users?
Absolutely. I think that's a great idea. So my experience with ACL starts in 2018. Well, first of all, ACL stands for Association of Computational Linguists. And it is an international association of scientists, researchers, engineers that deal with computational linguistics, which is the broad area that includes everybody that works with applying computational techniques to language. So as I said, my area, NLP, involves turning natural language into something that machines can understand, but there's a broad area of things you can do with linguistics. You can study, for example, how different languages share some things in common with each other. You can study how the tone of voice changes the way we understand each other. You can study which information is lost when translating. All of these things all belong to computational linguistics. And so ACL is a conference that brings together computational linguists every year or so.
You met the right group of people who can kind of tell some story about how this future of the LLM is going on. So can you share some overall impression about this year's ACL? Maybe some kind of something stood out for this year's conference?
Yeah. So the main impression that I got, as I said, was the sheer size of the event. So it's grown from last year, it's grown from when I started, and it's now reached very, very large proportions in terms of attendance. So it felt like an important gathering of like-minded individuals. In terms of where this growth was located geographically, I've noticed an interesting trend, which is there's been a dramatic increase of publications coming from East Asian countries where research in AI has been heavily invested. And I think these investments are finally paying off now. And we're seeing some very exciting research from China, Japan, South Korea had a lot of very, very interesting publications. So I met some great researchers from Seoul University. So overall, I had the impression that this particular part of the world is really investing heavily in AI and NLP research. And specifically about my area, which is argumentation technology and argument mining, I've noticed that the argumentation community has grown a lot. And I think that if I'm saying this a lot because it is my biggest impression that the growth of this industry, of this academic field, but for argumentation specifically, we're talking about, I think, a 5-fold growth with respect to last year. So the argumentation community gathers in a workshop that happens in the conference called Arg Mining, which stands for argument mining. And this year's Arg Mining was large enough that we had our own hall, whereas just last year we were still meeting in a sort of smaller room. So it was very exciting for me to see a renewed interest in argumentation. And interestingly enough, while, as I said, the growth of the overall conference seemed to be primarily coming from East Asia, the argumentation community seems still primarily located in Europe, which is where it originally was born. So my impression from this is that there's still huge room for growth. While argumentation has grown already quite significantly just due to how it's accelerating just in Europe, I think once it reaches those areas where AI is being heavily invested, like East Asia, that's when we're going to see an exciting growth for the area. So I'm really, this is really a personal hope that the argumentation community can become a truly worldwide phenomenon. And considering how much it's growing, AI is growing in East Asian countries, I'm hoping to see more and more argumentation research coming from here.
Very interesting insights.
Something else that I've noticed is, well, this year marked a complete departure from those traditional machine learning techniques that, as I said, were still the state of the art when I started walking in this area. So all the research at the conference was about LLMs, large language models. So in a way, we could say that LLMs conquered ACL, and by extension, LLMs conquered the AI community. But really, while this is an overall surface impression, what really stuck with me is that the AI community, the academic community, is trying to understand LLMs from a critical eye lens. So trying to understand what can these systems do, what are their potential, but also what are their current limitations. And the industry, for the large part, is collaborating with this effort. So many of what they're called the big tech companies were at the conference, and they're all focusing on different areas. Meta is championing open source models. So their LLM is called Llama. And while maybe many of our listeners may have not heard of it, it is a crucial resource for us researchers because it's a free model that everybody can download and use. So Meta has published their latest findings on more efficient and quicker training and less prone to bugs and errors. Google was at the conference sharing their findings on alignment, which means how can we make LLMs better at generating content that we as humans can relate to and that maybe marginalized communities can also find appealing to them. Apple has published groundbreaking research in speech. So text-to-speech and automated speech recognition this year has really grown into topics like, for example, detecting accents or changing the tone of voice. Very, very interesting research. So all the big tech companies, the traditional ones, were there: Microsoft, Amazon, IBM. Something curious that I found was that I was really expecting this year, since LLMs have become so big, to find the big players in the LLM field. So OpenAI, Anthropic, Mistral, these companies did not have a big presence at the conference.
Really?
Yes, and this really surprised me because I was expecting them to have like a stand or to sponsor, but instead they were completely absent.
Okay, yeah, that's unexpected. Yeah, can you tell me a bit more about that?
Yes, so I've discussed this with many of my colleagues at the conference, and our impression is that LLM companies like OpenAI are tackling this area from a different perspective that we in academia are. These companies are, at the end of the day, selling LLMs, or other than doing research in them, obviously. So I believe they have an interest into maintaining a sense of mystery around LLMs, a sense of mystique, whereas we, on the other hand, as academics, are trying to open them up and, I'm going to use a word that's a bit brutal, eviscerate LLMs just to...
Like a critical review.
Yes, just to understand what's really inside their thinking process. Whereas I think that LLM companies are trying to make LLMs sound like these obscure, fascinating, almost dangerous machines.
I see. So it's kind of the balance between the exploration versus exploitation.
Absolutely.
Looks like some players are more interested about the exploitation rather than the exploration.
Yes.
Yeah. So just right before the release of the GPT-5, I think the Sam Altman mentioned the GPT-5 feels like a Manhattan Project, which is gonna kind of. What do you think about those approach? Like, do you think they actually know how they're gonna end this game, or? So
the reason why I'm laughing is that no, personally, and this is just my opinion, of course, but I don't think that LLMs are like the nuclear bomb. First of all, Manhattan Project was a private, top secret military project. And it's interesting to me that Sam Altman thought of his work as a researcher in these terms, because I don't think that's what research should look like. Research in LLMs is open and public, so it's nothing like the Manhattan Project. And I would advise Sam Altman, if he feels like he's working on the Manhattan Project, he should attend next year's conference with us so that we can help him feel less alone in this process. But jokes aside, one thing that I understand is that for many companies, there's an interest into making LLMs sound like they are an event, something like a point of no return. Now we've reached, I've seen some CEOs of these companies refer to singularity or AGI, artificial generalized artificial intelligence. I think this is not the right angle to pursue this research because it's sending the wrong message to the community of LLMs as an enemy or LLMs as something to fear. I understand that this narrative may lead shareholders to invest because somebody sees a statement like this and they go, oh my God, these guys have the nuclear bomb and now I'm going to be part of it.
Absolutely.
But really, LLMs at the end of the day are a technology that generates language. And I think that rather than advertising them, because that's what it is, an advertisement, as something that's going to threaten our existence, like the nuclear bomb, we should instead focus on what can they really do. And when we approach this LLMs from this perspective, we actually notice that there's still a long way to go before LLMs can truly achieve intelligence. And you rightfully asked about what I think their end goal is, the end of the game. I wouldn't know because they haven't unfortunately decided to share it with us. But what I can share with you is the impression that I had by looking at the research that's been published at ACL this year. Many researchers have found some fundamental issues in the way LLMs think. And I believe these issues are something that requires huge attention from us.
I see. So the general sort of the voice that I'm hearing from the researchers at ACL is, it's kind of the way of typical way of how science progress. So in the science, let's say OpenAI announce something, and okay, you announce something, we're going to believe you, and it's not going to be how science progress. All the scientists kind of critically review and actually reproduced to prove it's actually wrong, can be wrong. That way, it can be kind of replicated to the wider community, and that seems to be how the science progress. Whereas the way the major industry big players are progressing doesn't seem to be aligned with that way. So looks like we have the right community who is looking at the LLM, this magical power, in the critical aspect. So what was the major limitation the researchers actually pinpointed about the LLM?
Thank you. That's an interesting question. So the main discourse about LLM's limitations involved what is commonly known as hallucinations. There was actually, speaking of OpenAI, an interesting blog post from OpenAI from the last few days about hallucinations and explaining why LLMs hallucinate and their own vision on what can we do to mitigate this issue. So as many users that use LLMs in their everyday life know, LLMs are not reliable agents. They make mistakes, and by making mistakes, I don't mean that they will sometimes make an error, go, oops, sorry, I meant to say 7, but I did the wrong calculation. What I mean is that sometimes they will generate text that is apparently absurd or completely incoherent. And we've all seen LLMs generate fake biographies or generate fake citations. The author of that OpenAI blog post mentioned that they managed to create a false biography of themselves with an LLM, complete with a fake birthday date. And the researchers have wondered why that's the case. And what they found as a community is that LLMs seem to struggle fundamentally with reasoning. This is the main limitation at the moment. So there was a lot of very interesting research pointing out at basic issues with LLM reasoning. So I can cite a few. There was an interesting article from the community at the Dundee ArgTech Lab from our academic advisor, Chris Reed, and his very talented students and collaborator about LLMs struggling with providing evidence-based claim verification, which is an important reasoning task that consists in deciding whether a claim is true or not based on some provided evidence. And by struggling, I mean that sometimes it was as severe as almost 50% of the responses being incorrect when prompted to provide actual verification for unseen claim. I've seen work that mentioned how LLMs struggle with abductive reasoning. Very interesting work. So normally we know reasoning as an inductive process. So LLMs work very well with this because they're language models, they're completion models. So if I tell them, you know A, you know B, therefore LLMs will naturally go, all right, C, because I've given them all the pieces of the puzzles. Abductive reasoning works in another direction. There's a popular game, at least it's very popular in the United Kingdom where I live. It's called Mastermind. I don't know if you've ever seen it.
No, I don't think so.
So it's like a small plastic puzzle where you have these round pins that you can put in a board.
Right.
And the way it works is I guess a sequence, like red, red, blue, green, green. You don't know my sequence, and you have to try.
Okay.
So you guess, and you go yellow, yellow, red, red, red. And I tell you wrong, wrong, right, but in the wrong position. So you know there's two reds and they're not here. So maybe they're here. And these three, well, this cannot be yellow because I already tried. Maybe it will be blue. So you keep making guesses and you discover something new.
Right.
This is abduction.
I see.
It's the process of reasoning by excluding all the possibilities and entering a space of gradual certainty where in the end, the only solution left is the correct one.
Yeah. So it's kind of hypothesis driven and kind of ruling out some alternative hypothesis to reach out the ultimate one.
Exactly, yes. Very fundamental type of reasoning, very important in some areas of mathematics, computer science, investigations. And what I found, there was this incredibly interesting article by my friend Federico Ruggeri from the University of Bologna, and he worked with some researchers at the King's College as well, and other researchers from Bologna. And what they found is that LLMs have fundamental issues with abductive reasoning. Now, this is disappointing, and it's not something that it's immediately obvious. But when they're stuck with, so when you exclude all the obvious possibilities and go, okay, so it's not A, it's not B, what do you think? LLMs will hardly go, oh yeah, it's C. So there was this interesting article from the University of Warsaw about exactly this issue of reasoning when all the possibilities have been removed. And I found it very interesting to look at. So the researchers asked the LLM this question, not exactly this question, it was a bit more complicated, but this was the idea. What is 5 plus 7? Choose between A or B. A was 0 and B was 20. Now 5 plus 7 is not 0 and it's not 20.
I see.
But the LLM had to choose between A and B. Now, if you try it at home, probably put it in your favorite LLM, it will say, well, 5 plus 7 is actually 12, so it's neither A nor B, which is the correct answer. And since this is a very easy question, LLM will be able to tell you that it's neither A nor B. But the issue is, when the question becomes more complex, at that point, what happens is that we found a bias in LLMs where they will feel urged to choose. And if you tell them that there's two options, even if they're both wrong, there's an incredible likelihood that the LLM will just pick one, because that pressure of having been given no alternatives just triggers something in the training process of the LLM that pushes it towards incorrect responses. Now, there were many other works like this. I'll just quickly mention Henrique Bayer's work on puzzle solving with LLMs, where she showed conclusive evidence that LLMs struggle with puzzle solving. So she showed the example of a complex puzzle, the zebra puzzle, where the LLM has a few constraints and needs to solve a puzzle. No results from even the bigger models. And I could go on naming more and more research like this, but the conclusion is, while LLMs do exhibit some side effects of reasoning, at the end of the day, when they're really cornered to provide evidence of their reasoning, they show fundamental inability to produce reasoning.
So yeah, the case that you mentioned, like given the wrong choices, it is kind of obliged to answer something, even though there's no correct answer. Okay.
So hallucinations are related, well, partially to the fact that LLMs are designed to give correct response. And in general, it's statistically more likely that you will give the right response by guessing or lying. Rather, if you say, I don't know, you're already admitting that it's incorrect.
Fair enough. Yeah.
And unfortunately, it's not as simple as teaching the LLM to say, I don't know.
So what I noticed was, the keyword reasoning. The reasoning has been appeared in many of the LLM companies. It looks like how you're using the word reasoning seems to be a bit different from what they call as LLM's reasoning. So can you explain a little bit more how do you define the reasoning keyword?
Absolutely. Thank you for the question. So reasoning is a concept that derives from ancient Greek philosophy. So it's a very old idea. And when you pinpoint the fundamental idea, reasoning is the process of distilling new knowledge from existing knowledge using formal inference or rational processes of derivation. So reasoning is the process of extracting new knowledge from existing knowledge through a rational approach. This definition is very general and includes what many believe to be reasoning. So what many believe to be reasoning is actually inference. Inference is reasoning from a premise and drawing a logical conclusion. And it is absolutely a form of reasoning. So it's the classic, if it's raining outside, I'll get wet. It's raining outside, what do you think? I'll get wet. LLMs are very good at inference. And when companies talk about reasoning mode, they're largely referring to this type of reasoning.
I see, yeah.
The reason why LLMs are very good is that inference has become, throughout the centuries, because of this Greek influence, and particularly in Western cultures where the majority of LLM's data comes, inference has become a quite common speaking pattern. So LLMs will use it all the time. We provide a short piece of premise and then a fact and derive a conclusion. We use it a lot. Like even if we're at the restaurant and say, oh, I'm a bit hungry and everything else is closed, so let's order here. It's very easy to make this kind of inference. And LLMs learn it from our language. But reasoning is a much vaster field. There's, as I said, abductive reasoning, which we're given an example a few minutes ago with the mastermind game. There's argumentative reasoning. There's deductive reasoning. There's many forms of reasoning. And I think when you look at these other forms of reasoning that are equally as important, and well, I have a bias towards argumentative reasoning because it's my area of specialization, so I would argue that it's maybe even more important, or at least just as important. You see where LLMs exhibit their incapability of true reasoning.
I see. Okay, I think you kind of covered well about the lack of reasoning ability, and you also mentioned about the argumentation. I'm just curious about how it is being applied, how the lack of reasoning capability, especially susceptible to the argumentation area. Can you tell me a bit more about that use case?
Yeah, so argumentation is, first of all, a type of reasoning. So let's start with trying to understand what argumentation is. Argumentation is a specific area of reasoning where two or more parties, often with opposite or polarized views on a certain topic, come together and engage in a discussion or an exchange of rational operations where these two polarities can produce or synthesize new knowledge, whether it's in the form of persuasion, in the form of critical thinking, in the form of decision making. But at the end of the day, argumentation boils down to two or more conversational parties having a certain opinion on a topic and discussing it together to derive new knowledge. So as such, argumentation is crucial to reasoning, as is a specialized form of reasoning. And it's particularly interesting because argumentation is a type of reasoning that is hardly done with one party. So I can reason by myself. If I have a problem, I can just put down all my information and do some form of inductive reasoning or abductive reasoning and derive a solution. But argumentation is not something that you do by yourself. You need a conversational partner to do argumentation. So it is particularly compelling that LLMs could be used as critical thinking partners, as argumentation partners. It's, I think, a very compelling use case, and therefore the community is pushing these models to truly start exhibiting argumentative behavior because of the huge potential that we as researchers, but I would say even at the even if that sounds dramatic, we as humans can benefit if these systems are able of doing argumentation.
Okay, I see. So I think we're kind of at the crossroad of the formal logic study, like a philosophical perspective as well as a technological perspective. What I was wondering was, I think you've touched upon this point. It seems to be very interesting point for the academia professional. But as a kind of normal users, like for example, I use LLM to book my meeting or like do some Googling or something like that. For that seems, those kind of everyday use cases seem to be a bit distant from the argumentation. So can you tell me a bit more about why this actually matters for the general users?
Absolutely. That's actually something that a lot of our listeners will probably be wondering right now. So yes, argumentation has a number of practical implications for users. When we think of argumentation, we often think of debates. So even the word argumentation in English has the same root as argument, which is a fight. So when we think of argumentation, we always think about two people arguing about something with the purpose of just convincing someone, whether the other party or someone else. But argumentation has a lot of practical implications in our everyday life. For example, teaching and instruction is crucial for argumentation, meaning that good argumentative thinking is essential for good teaching. And in a time when education, knowledge is becoming more and more important, and I would say that many people use LLMs to educate themselves. So one of the most common use cases for LLMs is, I don't know something, I want to learn more about a certain topic, I just open my LLM of choice and start asking questions about the topic. And I was a tutor at the UNSW for a few years, and during my teaching activity, I've seen many students use LLM in this way, so using it as sort of a teaching assistant, but even like people willing to learn more about the topic. And this is where the evidence and the research that emerged from ACL was very interesting. Many researchers this year published extremely interesting research on the fact that argumentation is an essential tool for teaching. And I'll give you a couple of good examples. The first example is the critical question generation task from the argument mining workshop. So this year workshop had a challenge for the community, which was generating critical questions to encourage learners to think about a certain topic. Now, generating critical questions doesn't necessarily require argumentation. You could just use traditional LLMs to do this, or other reasoning ways of generating these questions. But the winner of the challenge, the team from Ellis research team in Alicante, they found that these critical question generations reach their full potential when combined with argument mining. So basically, argumentative knowledge improves critical question generation so much that their model outperformed every other model. And I had a chat with the other participants in the challenge. So many of them ended up using argumentative technology one way or the other. Another very interesting work by the Al-Khatib team, they used argument schemes. These are very traditional ideas that, again, come from ancient Greece, but are as recent as Walton's ideas on argumentation. And these are schemes of thinking that sort of describe the way we form our thoughts. So when we reason, when we think, we tend to stick to certain patterns. And their model used these patterns to understand the learner's weaknesses and produce critical questions. So all these works all showed how critical question generation, which is an essential tool for learning, because learning at the end of the day, teaching at the end of the day is giving you information and asking you questions to verify that you understood. So it's 50% of the teaching process, and there's evidence, conclusive evidence, that argumentation helps. Another very cool work that I've seen in this area was a work by Dr. Romain Puig about productive failure. So this is a very interesting concept from learning science, and it's about how we can teach learners by exploiting their failures. So you try to respond and you fail, but you learn something from your failure. So this kind of iterative providing knowledge and reflecting on your knowledge eventually leads you to form new ideas. And again, their work used a number of techniques that went beyond traditional LLMs, including some argumentative techniques. And I think it just shows more of the importance of argumentation for teaching. So I think this is a great example of how during our everyday life, we may benefit from an LLM that is able to think argumentatively, challenge our thoughts, and in a way really push us to improve our own critical thinking and our own ideas.
That makes a lot of sense. Yeah, so the word argumentation felt a little distant, but when I hear what you're telling, I think that kind of resonates with lots of department of the education kind of proclaims. For example, the government of the New South Wales, they released their own chatbot, which is aiming to the children, making not lazy, but more smarter. So yeah, that's I think they wanted to kind of encourage the critical thinking rather than making the children lazier, because you know the next generation will be growing up with this new technology embedded. So yeah, and I now see the importance of the argumentation for the correct use of this technology. And also that kind of remind me some voices from the industry leaders, because more of our corporate clients, they're kind of interested in automating their decision-making in their corporate decision-making process. Do you see some relevancy in this field as well?
That's interesting. Yes, I think so, because there's definitely a connection between argumentation and decision-making, even from a business perspective. So you made me think of an interesting paper that I saw at ACL about Dr. Jo-Soon Park and Dr. Claire Cardy. They worked with an American department for the collection of consumer debts. So this is public department, and sometimes they ask customers their own feedback on how they can do better. Now try to ask feedback to someone who's having to be collected debt. A lot of the feedback will be insults. This company, this branch of the US government was struggling with trying to understand which of the feedback that they've received is actually useful.
I see.
And this is money for them, because their decision-making process as a company depends on whether they'll be able to act upon the requests from what's essentially their customers. And so these researchers provided a tool where they could use argumentation techniques to filter out argumentatively irrelevant content. And they found it hugely beneficial for the company. So this is an example of that I've seen on how to use argumentation to sort of improve decision making in a company. But I believe there's huge value in using argumentation. So I've recently read that there's this book, The Craft of Argument by Williams, an incredibly useful book for anyone interested in argumentation and argumentative writing. And apparently it's been cited by some important business leaders as huge help with their critical thinking and decision making. So there's something about argumentation that resonates with business decision making from my perspective.
Absolutely. I can't agree more. I think even with the old decision making situation, I think there are some two main categories of the decision making. One is the operational, and another is strategic. So operational, there's a kind of certain decision. You just raise the yield rate or efficiency, just one direction. Whereas the strategic decision making is kind of multi-direction. So your argument, my argument, and someone else's argument may be more right, and you're kind of need to see the argumentative quality of each own's claim. And at the end of the day, someone who makes more compelling story is kind of the influencing the decision making. So it looks like it's even more prominent for the strategic decision making needs a bit more sort of argumentation capability.
Strategic decision making, so that's even more relevant to the issues that have emerged. So the paper I've mentioned earlier by Henrik Bayer about the puzzles, they were all based on strategies. So that's a key area where LLMs struggle, coming up with good strategies to solve problems, which I think is directly tied to what you explained about strategic decision making.
Thank you very much, Stefano. Yeah, it was really super helpful to understand what argumentation is and the importance of everyday life as well as business decision making situation. And I want to ask one more important question, which is how to make that happen. Like, we got nice ideas and just wonder about your view, how we can enable to LLM to actually do some argumentation.
I've been asking myself that question for a few years now.
$1 million question, I guess.
Yes. So this was actually the driving question behind my research as a PhD student. And there's many researchers trying to understand how we can enable LLMs or any language model with these kind of argumentative reasoning capabilities. And of course, we still don't have a response to that question, but there are some signs that point in the right direction. So my personal finding as a researcher was I've explored how to embed argumentative thinking in LLMs. And during my research, I've developed a fine-tuned version of the Llama model from Facebook. This model was obtained by taking the Llama LLM, so the pre-trained LLM that came from the Meta researchers, and add additional data from argumentative website called Kialo. This website contains online debates between users that discuss on popular topics. So they will maybe discuss political things or like even practical things, which is better, A or B. And they provide their own idea and they create what we call an argument map on the topic. So a tree of all the different claims and ideas and how they're connected to each other and how they attack and support each other. And I use this data to sort of teach the model how to better understand these argumentative relations, a process that we call fine-tuning. And then during inference time, I used another model, a non-LLM model, a sort of more deterministic model, if you will. It's still a neural network. It's called LSTM, but it's a hierarchical structure of LSTM. So for those that know a bit of neural network, it's an architecture called tree LSTM, and it was embedded into my model together with some embeddings for the input. And I also used some techniques of specified attention called utterance manipulation strategies that taught my model how to detect the importance of certain keywords in the sentence. By combining all these things, the model was able to very precisely detect whether a certain node in the argument map was attacking or supporting another. And this kind of hybrid between LLM and the specified machine learning yielded a model that was, in my opinion, very interesting from an argumentative perspective. So we ran tests on how this model performed. And what we found is from automated metrics, so we used a metric that we invented. It's called ArgScore, and it measures the degree of argumentative relevance of the sentences generated by the network. But we also asked people. So we had experts in linguistics play with this model, and they used it for a few hours. And it was a double-blind study where sometimes they would use our model and sometimes they would just use the regular llama. And at the end, there was a questionnaire asking, do you think that the response given by the model that you were debating with was argumentative enough? Did it challenge your point of view? And the majority of our testers, a significant majority, found that the model fine-tuned on these argumentative data from Chialo had more argumentative capabilities. And then we looked at the data, and even I, looking at some of the results, I found that the difference was quite important and easy to perceive. So I'll give you an example. There was this debate on the future of AI, so surprisingly appropriate
Very
for
much so, yeah.
our talk, yeah. And one of the users that was testing the model, they said something like, "Oh, I heard an article from can't remember which researcher that said that LLMs are going to replace all of our jobs." And the regular Llama model gave a very eloquent, very polite response, like, "I understand your concerns. I think the researcher you mentioned is very renowned, and you should take their opinion into account. However, sometimes opinions can be biased, so you should really read into others to make your opinion." So the LLM was basically not really taking a stance on this idea, whereas our fine-tuned model that was designed to argue with the user was able to say, actually, that article was disproven. There's evidence that that is not true. Therefore, you should not trust that source. The response was a lot more concise and to the point. And many people may maybe not like it compared to this more generic response that LLMs normally make. And in fact, some of our testers found the response from the traditional model to be more eloquent, but the response from the fine-tuned model was exhibiting clear argumentative behavior. And I think that was a glimpse into what we can do with LLMs when we combine them with other types of reasoning techniques that aren't just based on generating new tokens based on a statistical function.
Yeah, that makes a lot of sense. So it looks like, as far as I understood, the idea is to have some structured information about how you're thinking, like a conclusion or premise or reason and evidence, and then we're kind of injecting the bone of the thought into the LLM, which kind of generates something fluffy part, but we're injecting some meaty part of the thought into the LLM. So perhaps by combining those two, looks like you're able to kind of generate some argumentative capability. Do you think it's kind of relevant to the general people? Because you mentioned like a debating situation where it's kind of a more formal situation where they're supposed to debate, but in the normal life, even though you're argued, that may be kind of based on not really logical reason. Do you think it can be useful to train them as a better thinker?
I think so. I actually have a great degree of confidence that these techniques can truly become a way to train models that are better equipped at helping us think. And I'll give you a good evidence. So recently, at DeepSkill, we collaborated with an academic institution with a number of students that had to face an exam, and they engaged with a dialogue assistant that we created that was based on some of these techniques that involved combining LLMs with argumentative information and the semantic information that was extracted with the scheme extractor. So basically injecting this schematic information. The students found that the assistant was much more humane and understanding than the regular LLMs that, as I said, they are very familiar with. So when I heard this, I was pleased, because it's always nice to hear that something you built was of value to someone, but I wasn't surprised, because I think that a system that is able to understand argumentative thought and reasoning ultimately will help you produce more clearer thoughts, and will also be able to understand your thinking better, which was at the root of what pushed me into this field, the dream of having a machine that really understands you.
I see. That's very impressive. Very well done. So you're kind of making your dream as a kind of imaginative machine is doing some argumentation. That sounds like a very futuristic, and you're making it a bit more realistic product. Very impressive. Yeah, very impressive. So yeah, I think we covered quite a lot. So we kind of covered how we are seeing where the machine's capability are at and what you are thinking is important. And just wondering what's going to be the next, where the academia or yourself sees how this wave is heading to. Can you share any insights about the possible future scenario?
Absolutely. So predicting future is not something that scientists tend to do. We all want to know what's next. And a lot of researchers have wondered what can be the next step for LLMs to become critical thinkers, or for LLMs to help us become better critical thinkers. This, as I said, goes into how can we equip LLMs to produce reasoning, true reasoning, like abductive reasoning, argumentative reasoning. And there's various directions that this can go. One interesting thought-provoking idea that I heard at the conference was from researchers at Meta that argue that many of the issues that we have with LLMs are due to tokenization. So LLMs use as input natural language, of course. And this is this brings up a fundamental issue in my area that we've been working on since I started, but probably even earlier, which is language is not made of zeros and ones. So machines are not capable of understanding our language. This means that you cannot just put input text into a machine and ask a response, because to that machine, that is just a random string of zeros and ones with no meaning. The issue becomes even worse, because words, unlike pixels in an image, they don't contain any meaningful semantic information in the vast majority of languages. So the word apple and the word orange are both fruits, so they're very similar to each other. But the sequence of letters A, P, P, L, E and the sequence of letter O, R, A, N, G, E, there's one E in common. And it's the same letter that's in common with letter or like noise. So basically what I'm trying to get to is that words don't contain any semantic information. And so we've always dealt with this issue that's unique to language processing, which is how do we encode words in a way that machines can understand? And the task of dividing our language into chunks of relevant information for a machine and embedding it into a series of numbers that mean something to the machine is known as tokenization or vectorization. And what these researchers are arguing is that the fundamental issue of LLMs is there. There was this very funny blog post that one researcher shared that said that tokenization is the root of all evil. It's the reason why LLMs hallucinate. because they recognize sequence of tokens and they think it's relevant, is the reason why LLMs sometimes will give grammatical responses. So it's an interesting line of thoughts, and it's brought up some very exciting new architectures. So there's this new architecture that's been proposed at Meta, which instead of using tokens, it uses byte stream. And there's layers that encode this byte stream into chunks that can be passed to the network and then decode them. It's quicker because it doesn't have to store these chunks, these words into memory. And it's also more precise because it doesn't rely on statistical occurrences of tokens, but rather on bytes, which contain a lot more nuanced information. So maybe the future of LLMs is not to change the behavior, it's just to change the technology and to find something that goes beyond a sequence of words and into a more granular representation of meaning. Of course, there's other ideas that are coming from the literature. Another interesting line of thought comes from multi-agent systems. So multi-agent systems are an exciting new idea. We're experimenting with them quite a lot at DeepSkill as well. And they are very clever solutions to embed reasoning into LLMs. They consist in combining different LLMs together to provide different outputs and then having a mean or a consensus on these outputs. This can be as simple as asking 5 LLMs and then combining the responses, to as complex as something like these new multi-model architectures. Very cool, very fancy architecture. I've seen one that's called FlexOlmo from Allen AI Institute. Very cool architecture that creates specialized modules within the LLM for certain tasks. So maybe the future of LLMs will be to create different modules inside the LLM that specialize in different parts of reasoning. And maybe these modules together can produce reasoning as an aggregation of different elemental generative processes. My personal belief is that the future of LLMs lies into something that researchers are increasingly referring to as Neuro-Symbolic AI. Neuro-Symbolic AI is the process of combining neural networks, so traditional data-driven content generation, with symbolic reasoning, which is formal, strict, logical representation of thought and formal, strict inference. I've dabbled into the concept. As I said, I've done a fair degree of neurosymbolic reasoning for my thesis, and I found that there was some very good results from neurosymbolic AI in solving reasoning issues. Other researchers have argued for the importance of neurosymbolic reasoning. So the team from ArcTech at Dundee that I mentioned earlier, they also strongly believe in neurosymbolic AI. So when I asked Henrique Bayer, the author of that paper that showed LLMs incapable of dealing with puzzles, what she thinks is the next step, she also agreed it's probably some form of neurosymbolic AI, but there's a lot of different articles from the conference that use neurosymbolic AI for language generation, for translation, for all sorts of different linguistic tasks. And so this is definitely an area that is exciting researchers. The main issue with neurosymbolic AI is that LLMs at the moment have a way of processing input that is based on statistics. So whether LLMs can use symbolic information in their prompt, that is not clear, because the symbolic information will be turned into tokens. And so we're falling back into neural approach. We can go the other way around, which is taking the LLM's output and using that inside a formal reasoning system. And I think that's closer in a way, but still not there, because then you're tied to all the issues that made traditional symbolic reasoning unfortunately obsolete, which is that you have to hard code, as we say in software engineering, a solution for every problem rather than having a general purpose solution. So maybe in the end, it will be a combination of these approaches, or a system that is able to generate these symbolic reasoning trees and then combine them with traditional neural reasoning. We're going to continue thinking about this and making experiments. And I'm really excited to see what comes next, because I think that this area of reasoning with LLMs will drive the next generation of AI systems that will truly become useful partners in thinking, decision-making, and ultimately producing better ideas for everybody.
I see. Yeah, that makes a lot of sense. So it looks like you're kind of combining the bone of the foot and the flesh all together, which is kind of a symbolic and as a neuro-symbolic approach. So
Yes.
hopefully that can generate really, truly thinking machine as you described. So neuro-symbolic AI, that's really indeed a very interesting approach. So you're kind of joining the bone of the thought and the flesh of the thought as a kind of a symbolic, and neuro as a neuro-symbolic AI. So it looks like that's a really interesting approach to enhance the reasoning capability of the AI. My last question is, how do we know we're actually achieving our goal? How can we measure?
Hard question. And I'd say that it's a question that's very uncomfortable for many researchers, because since LLMs came into play, we've been having a huge struggle as a community to evaluate our models. The reason is that language generation is a task, and dialogue in general is a task that's very hard to evaluate. Now, traditionally, let's go with the beginning. Early language generation systems were measured with metrics that measured similarity with the state of the art. These metrics, I'll name a few, maybe some of our tech-savvy listeners may have heard of them. There's the Rouge score or the Bleu score, BLEU. So these scores are basically measuring whether the generated output from the model resembles an output that I had in mind. So I wanted the LLM to say this, it said this, how similar are these two? The issue with these metrics is that there's not only one possible response when dealing with reasoning. And we don't want the LLM to be constrained to say a certain sequence of words all the time. So it's not a suitable evaluation metric to just take a response, take some response that I have in mind, and check word by word whether the LLM said exactly what I thought it should have said. So, knowing that measuring word overlap with some golden response that I have in my mind is not suitable, this leaves us with the burdensome task of how do we evaluate the output of LLMs, and how do we measure whether they've achieved reasoning? This is, in my opinion, a very exciting area to do research in, because it will lead the next chapter of LLM-based research once we find a way to measure this. And I don't know what the right answer is, but I think that any good answer must be based on human evaluation and some kind of statistical similarity with human evaluation. So what I've done for argumentation is I've used the perplexity score of an argument relationship classifier as a metric to measure whether the response was argumentative enough. To verify whether this was a good metric or not, I asked humans to evaluate the system. And if 80% of the humans agree with my metric, that means that the metric is suitable. So finding an adequate metric will be a challenge. We will have to think very hard about which aspects we want to evaluate. Maybe it will be some sort of statistical likelihood then of the response. Maybe it can be some clustering method where we give the LLM a set of candidate responses and we measure average similarity with them. But at the end of the day, it needs to be something that correlates with human judgment. And I think that that's where we will be able to know that our evaluation metric is truly something that we can use in practice. So I think that this issue of evaluating LLMs is probably where the majority of our focus should go before we think of delivering the next line of systems. And I want to conclude this discussion on evaluation with something interesting. There's many researchers that have responded to your question with, well, I know how we can evaluate LLMs accuracy. We ask LLMs. So
oh well.
this sounds funny,
Yeah.
but I've seen many papers that use LLMs to evaluate whether LLMs have produced the right response. Sometimes the same model that they're trying to evaluate used as a judge. I wholeheartedly understand why this is a compelling approach, and I even see value in this approach up to some degree, but I think we should be very cautious in using this as an evaluation metric. And I know this sounds like a very picky approach where, I want to be very strict, but I truly believe that evaluation should be done properly, because once you trust evaluation metrics, then you trust all your findings. And so your research is built on very good foundation. Whereas if your evaluation metrics are a bit iffy, then you're building on something that's going to fall. I actually learned this myself during my research as a PhD student, because the first version of my system, I used these metrics like bleu and rouge to measure the quality of my system. And I thought that it was very good because the metrics were very high. And then when I tested it, I realized that it wasn't good at all. So in hindsight, I learned the importance of creating better metrics that correlate with human judgment before you start building your system and iteratively increasing its set of features.
That's quite interesting. Like asking LLM to the quality of the LLM. That sounds like my kids completed their homework and scored by themselves, which that was really indeed interesting discussion. Just before we wrap up, is there any kind of last words you want to leave to the our audience?
So I think that if I can give you my personal recommendation of what to do with LLMs, try to treat them as they are right now, which is language generation systems, and challenge these models critically, and always expect critical reasoning and argumentative reasoning from the models you interact with. This expectation will lead your understanding of technology. So when you're unsure about whether a technology is suitable enough for your task, try to challenge it from the lens of argumentation. Try to look at it rationally in terms of whether it can truly provide the fundamental bits of its reasoning. Ask for the sources, ask for the evidence, ask from where this information came from, and try to prompt the LLM to justify what they think is correct. Even use small tricks to challenge it and see whether it's producing the right response. And in the meantime, keep an eye on our work and the work of other talented researchers to look forward to the next chapter for these models. As for the people that are following us that are interested in doing research in this area, as I said in the beginning, interest in argumentation is exploding. And personally, I found this area to be tremendously fascinating. So if you're considering your research to be grounded on how to produce more intelligent language generation systems that are less prone to errors, I really encourage you to have a look at the literature on argumentation, at our incredibly talented community. I cannot recommend more a great article published by our academic advisor, Professor Chris Reed, that's called Argument Mining, an Introduction, and will give you an overview of all the fundamental techniques in this field. It was a great read for me. It helped me dip my toes into this area. And then you can continue maybe looking at the anthology for the recent ACL conferences. And specifically, if you want to learn more about argumentation, there's the Arg Mining workshop. We'll leave a link for you to access it that can give you an in-depth view of how we're using argumentation technology to improve the thinking of LLMs. And yeah, if you're interested, reach out to the community, reach out to us, because this is a big challenge and we need as many like-minded talents to join us as possible, I think.
Absolutely, absolutely. Thank you very much, Stefano. That was really indeed useful and practical insights. Thank you very much for your time.
Oh, thank you, and thank you. This was a great discussion.
So I think we could hear some voices from some researchers who wanted to dissect what the actually LLM is, rather than just being kind of discussing some fluffy hype. So by that way, we can sort of have a critically view what this technology is and what's the better way to make it to think like actually human. And Stefano also introduced some novel approach to enable that argumentative reasoning capability of the LLM. So hope you got some insights from our session, and thank you very much for watching.
Thank you.